Hello everyone, welcome to part 2 of permutations. We've already covered permutations in detail, wherein I've started with the basics of permutation and combination. So if you have not seen that lecture, you can go back and check that lecture and come back to this particular video. So let's start with few PYQs. As you know the drill, I start with the basics concepts, then I take few PYQs. Alright. So before we dig deep, let's just revise and understand what is the basics of permutations and combination, how these two are different. In the previous lecture, I've told you, whenever we talk about permutations, we in general talk about arrangements. And when we talk about combination, we talk about selections, right? This is the most basic difference between the two parts, that is the permutation and the combination. Now, let's understand these in detail. So when we talk about permutation, we are talking about the number of arrangements of elements in which the order of the elements matter. Now, what do I mean by this statement? The order of elements matter. Order, that means in which particular order they are positioned. The position of the elements would matter. Let's take for example a simple word. Let's say we have a word as cat, or you can take this as three different elements or three different persons standing, right? Now if I write here TAC, I'm considering all the three basic elements. The elements are same. C is present here, A is present here, T is present here. The elements are same, but their positions have been changed. Since you change the position of a particular element, it gives rise to a new arrangement altogether. Therefore, we call it a different permutation. The order of the elements matter. So if you change any particular order, it gives rise to a new arrangement, and that is how we keep on permuting the values. So that is the most basic part of permutation. Now let's talk about combination and how is it different from the permutation part. How is it different? So when we talk about combination, we particularly talk about number of selections of elements in which the order does not matter. Does not matter. Now, what do I mean by this? Let's take up an example. Let's say we have cat here. In how many different ways can you select three elements out of three elements? The answer would be 1. Now, I'll explain the formula and then I'll come back to the combination. When we talk about this, we have the basic formula as NPR. And how do we break NPR? We write it as n factorial upon n minus r whole factorial. The formula for combination stands as NCR. And what is NCR? NPR upon r factorial. Now what is this? This is simply n factorial upon n minus r whole factorial. That is the formula for permutation upon this r factorial. This r factorial. Okay. So if we talk about a particular word, let's say we have, how many different ways can you arrange three elements out of three elements? Arrangement. So we are talking about permutation. When we talk about permutation, the formula is NPR, and that would be simply 3p3, and we know this is 3 factorial upon 3 minus 3, that is 0 factorial, and this is 3 factorial upon 0 factorial. What is the value for 0 factorial? That is 1. So it is basically 3 factorial upon 1, or 6 ways. Consider any particular. Let's say we have started with cat, so let's go with cat. What are the arrangements? So one of the arrangement would be A, C, T. Next arrangement would be ATC. Next arrangement would be CAT. Next would be CTA. Next would be TAC. And the last one would be TCA. We have seen we have got how many arrangements in total? We have got 6 ways or 6 arrangements in which all in all. Now, if I change this question to instead of arrangement, in how many ways can you select? You are just selecting, you are not looking out to arrange these elements, you are just trying to pick values. 3 elements out of 3 elements. How many different ways? You have to pick all. You have to pick all. Okay, so now we are talking about combination. And for combination, we know the formula is NCR. And how do we break down NCR? We write it as NPR upon R factorial. So this would be nothing but the formula for permutation, that is 3 factorial upon 3 minus 3 whole factorial upon 3 factorial. Now, it's very clear. We have 3 factorial and 3 factorial cancelling. 3 minus 3 is 0 factorial. So 1 upon 0 factorial. And that is again equivalent to 1. So one way. Now what is this? Even if you write this cat, so you pick any particular combination out of this. It is the same combination. That means we are talking about these 3 elements. The order does not matter. The elements are not changing. Yes, if we change the element, if we write TA, the elements change. It is a new combination. So when we select all in all or NCN, it is always 1. I hope this is clear to everyone. You're finding the difference between these two. When we talk about combination and we are selecting all in all, combination means how many elements are there? Are you changing the elements? No. The order does not matter. The order does not matter. So if the elements are same, it gives rise to just one combination. What would be a different combination? If you only pick, let's say, a single element out of this. So C or CA. But CA and AC, these are not two different combinations. These are two different arrangements. But the elements are same. Order does not matter. So they remain the same combination. I hope you have a basic understanding of the combination part as well. Now, okay. Now let's talk about few assignment questions that we have discussed that I've given you as part of homework in the previous lecture. So these are on the easier end. Find the number of rearrangements for the following. We have got 4 questions here. Okay. Number of rearrangement. The keyword here was rearrangement. We are not looking out for arrangements. Had the question been asked for arrangement, my answer would have been simply all in all. So 7p7, and this can also be simplified as 7 factorial. So what is the value for 7 factorial? That is my answer. But we are looking out for rearrangement. What do I mean by rearrangement? Let's again start with cat. Let's say our word is cat. And I ask you, what is the number of arrangements for the word cat? You all know the answer. That is 3 factorial, which is 6 arrangements. And if I ask you, what are these arrangements? You would be writing it as in the alphabetical order A, C, T, first arrangement. Second arrangement would be A, T, C. Third arrangement would be C, A, T. Fourth would be C, T, A. Fifth would be T, A, C. And the last one, sixth, would be T, C, A. These are the arrangements in alphabetical order. Now, if you look carefully, the cat, the word cat, is also contained as one of the arrangement out of these 6 arrangements that we're talking about. Number of arrangement, the answer is 6 for this particular question. Number of rearrangements, in how many ways can you rearrange this particular word? The answer is always total permutations or total arrangements minus 1. because we tend to omit that particular arrangement. In how many ways can you rearrange this particular word? So the answer would have been 1, 2, 3, 4, 5. So that is 6 arrangement minus 1, which is 5. Simple words, simple changes in the question might result in a different solution altogether, and here we have to be a bit careful. Now, you tell me what should be the correct answer. You all know this is 7 factorial. Rearrangement, so rearrangement would be 7 factorial minus 1. That is my correct answer for this. Now, what about the next one? This is all in all different. So 5 factorial minus 1. That is my answer. Now, when we talk about the next one, we have 1, 2, 3, 4, 5. We have 5 different elements. So we can call it again 5 factorial minus 1. Basics. This we have covered in the previous session. So therefore, I'm just quickly solving this. Now, when we look at the last question, we have H and here also we have H. So this is a question of similar objects, right? Or we can call it repetitive permutation. This we have not discussed in the previous lecture. So first we'll talk about how to solve for repetitive permutation, and the answer is simple. You solve the total number of permutation. When we talk about rearrangement, subtract 1, that particular arrangement. That should be my answer. Okay. But before that, let's do a question on this year's paper, that was 2023's paper. A question on permutation. How we can proceed with this? You'll see this was asked for this particular year. There are 5 persons. What are these 5 persons? They are named as P, Q, R, S and T, and each one of them has to be assigned one task. You have to assign one task to each 5 persons. So there are, let's say, 5 tasks. Alright, and there are 5 persons. Okay, there are certain conditions given here. It is always advisable that we start with this condition, wherein it guarantees me certain things. Now, if you look here, it is guaranteed that task 2 must be assigned to either R or S. You cannot assign task 2 to either P or Q or T. You cannot do that. That is for 100% surety. So here we make different cases. Case 1, wherein we write this as 5 tasks, 1, 2, 3, 4 and 5, and task number 2 is assigned to R. Because task 2 must be assigned to either R or S, and therefore in case number 2 we assign first task, second task, fourth, fifth task. Second task must be assigned to S. Those are the only 2 possibilities that we have. Now, we try to solve this question individually in terms of solving these cases individually. How do we do that? Okay. How do you assign? We have how many options? P, Q, R, S and T. 5 persons. You know for a fact R is assigned to task number 2. You know this with certainty. Therefore, you can say this can be done in one way. When you know for sure, right? Okay. It also says neither P nor Q can be assigned task number 1. So P and Q cannot be placed here. So out of the option set that we have, R is already used here. So I'm taking out R. P and Q cannot be used to fill task number 1. So for task number 1, you can only assign either S or T in case number 1. So this can be done. That is, task 1 can be filled in 2 ways. Right? Now let's understand this. Let's understand this quickly. Out of the 5 tasks, you have assigned 2 tasks. How many options do we have now? We have 3 places left, and we have out of P, Q, S and T 1. So we have 3 options. So any of the next task can be done in 3 ways, 2 ways and 1 way. So what is the correct answer here? 2 into 1 into 3 into 2 into 1. That is 12 ways. Now let's quickly solve for case number 2. Same method. We have the option set as P, Q, R, S and T. Whom are we assigning to task number 2? S. This can be done in 1 way. Now S goes out of the option set. Again the question says P and Q cannot be placed in the first task. So for task number 1, we cannot place PQ, we cannot place S, we can only place either R or T. So this can be done in 2 ways. Now, out of the 5 tasks, 2 tasks has been appointed or assigned. Therefore, in order to fill the remaining 3, we have got 3 options. So any of the next task can be filled in 3 ways, next 2 ways and 1 way. So again the answer is 2 into 1 into 3 into 2 into 1. That is 12 ways. Now since I'm explaining this question, I took some time to explain this question, but as you can guess, once you know these concepts, you can very well solve this within 1 minute. It is hardly going to take your 1 minute if you solve this. The correct answer is, since we have cases, the final answer is always the summation of the cases. So case 1, case 2 added up, it gives 24 ways. 24 ways is the correct answer for this particular question, option D. This was asked in this year's paper. And considering this year's paper, it was one of the toughest, no doubt about it. This year papers was one of the toughest papers. But we have got few questions that were on the easier end. I'm not denying the fact that this year papers was easier end or moderate. This year's paper was tough. But as you can see, we have definitely got few questions that were on the easier end. And talking about this particular question, it was a repetitive question from 2015. Just read this question. It has been asked in the year 2015. Same question with almost similar option as well. There are 5 tasks and 5 persons. Task 1 cannot be assigned to either person 1 or person 2, and task 2 must be assigned to either person 3 or 4. Every person is to be assigned 1 task. In how many ways the assignment can be done? The answer is 24. I hope this is clear. Alright, now let's quickly talk about repetitive permutation is what we have left out as of now. We'll cover this, but let's talk about, since we are in a flow of solving questions, let's solve few questions and then we can go back to the repetitive permutation part. No worries about it. Okay. How many different ways can 5 boys be arranged in a row so that 2 particular boys are always together? Okay, let's say we write here boy 1, boy 2, boy 3, boy 4, boy 5. 2 particular boys are always together. Let's say we pick these 2. Irrespective of whom we pick, it will not affect our answer. 2 particular boys are always together. So always together means group them together. Now, if we count the number of elements, we see it is 1, 2, 3, 4. Box will be treated as a single object. How many elements now? 4 elements. How many ways can you arrange these 4 elements? 4 factorial ways. But this was our assumption. Since this was our assumption, you know you need to break the box. How do you break the box? Just look at the number of elements inside the box. 2 elements, are they different? Yes, these are distinct elements. So they can be arranged in 2 factorial ways. What is the correct answer? 24 into 2, which is 48 ways. I hope this is clear. Alright, let's move forward. Let's understand few boy and girl questions. How many different ways can two boys and two girls be made to stand in a row so that they stand alternately? Very important part. The key word here is they are standing alternately. Alternate means if a boy is here, the next one has to be a girl. The previous one has to be a girl. Next to a girl has to be a boy. This is an alternate arrangement. We cannot consider this as an alternate arrangement. This is not an alternate arrangement. Please understand. This is not an alternate arrangement. This is an alternate arrangement. All right. Let's see what could be the different cases here. Okay. We can start by filling boy first or girl first. So we have got 4 positions here. Case 1 wherein we start by the girls. So girl number 1, girl number 2, boy number 1, boy number 2. Alright. Case 2, we start with the first position for boy. Now the third position would be for the other boy. Girl number 1, girl number 2. Now what happens? These girls will only rearrange themselves among these 2 positions, that is the first and the third position. The boys will only rearrange themselves in the even positions in the first case. In the second case, the boys would rearrange themselves in the even places and the girls would rearrange themselves in the odd places. Why? Because that is how they would be standing alternately. Otherwise, they would be mixed here and this is not an alternate arrangement. Okay. So, if you do this manually, let's just understand this question. If you try to do this manually, you can say girl 1, boy 2, girl 2 and boy 1. Yes or no? Or you can write it as girl 2, boy 1, then we have girl number 1 and boy number 2. Or we can write it as girl number 2, boy number 2, girl number 1, boy number 1. These are the different cases. So if we have to solve this, let's say the question would have come for 8 boys and 8 girls, then this is not the right approach. But you have to always make cases. And how do you proceed with the cases? Just understand. In order for the boys to occupy places, how many places the boys can interchange their position? 2 places. How many places girls can interchange? 2. How many girls are there? 2. So for boys can be arranged in 2 factorial ways. Girls can be arranged in 2 factorial ways. The answer comes down to 4 ways. And here also you have seen the answer would have been 4. Again, let's solve this. The girls can be arranged in 2 places in 2 factorial ways. The boys can be arranged in these 2 positions only, and they can be arranged in 2 factorial ways. So this is 4 ways. What should be the correct answer? Case 1 plus case 2. What is the final answer? 4 plus 4, which is 8 ways. Alright. Take some time to sink this concept because we'll start with different number of boys and girls. When we have, let's say, 5 boys and 3 girls. In that case, how do we start with this, or how does the question change in that particular scenario? That is an important part. Alright? Okay. Let's take for example, we have 3 boys and 3 girls, and again the same question, they are made to stand alternately. Okay. Case number 1, we can start with the boys. So boy 1, boy 2, boy 3, 3 boys. Girls would be girl number 1, girl number 2 and girl number 3. Or we could have started with the girls. So girl number 1, girl number 2, girl number 3, boy number 1, boy number 2, and boy number 3. How many positions? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How do we solve this? We start by looking at the boys. Boys can interchange their position, but always in the odd places. Girls can interchange among themselves, but always among the even positions. Among these three positions only. They can interchange, but among these three positions. So when we talk about the total number of arrangement for the boys, there are 3 boys and there are 3 positions. So boys can be arranged in 3 factorial ways. Girls can be arranged in 3 factorial ways. So this is 36. Now what about the next one? Girls can be arranged in 3 factorial ways. Boys can be arranged in 3 factorial ways. So 6 into 6, that is 36. What is the final answer? The final answer is always the summation of the cases, that is 36 plus 36, which is 72 ways. So in 72 ways, 3 boys and 3 girls can be made to arrange in a row, or they can stand in a line in a queue, wherein always they are standing alternately. In none of these 72 ways can one boy and the other boy stand together. This is not happening. In these 72 ways, it will always give rise to one boy, one girl, one boy, one girl, one boy, one girl. Or you can start with a girl and you can end with a boy. Something like that. I hope this part is clear and you are following this. It's an important question because you see, now when we talk about changing the number, you know what the question might be. When we talk about, let's say, 6 boys and 6 girls, the answer is simply 6 factorial into 6 factorial into 2, because you are adding that same value. Case 1 and case 2, only 2 cases when the number of element is same. When the number of element is same, it gives rise to only 2 cases, not more than 2 cases. That's it. I hope this is clear. Okay, let's look at few variations in the question. Okay, how many different ways can 4 boys and 3 girls be made to stand in a row? But there is a catch, they are standing alternately. They are standing alternately. Now the number is not same, they are not equal in number. So if you would have started with, let's say, boy here, boy 1, boy 2, boy 3, boy 4. Now girl number 1, girl number 2, girl number 3. How many positions? 1, 2, 3, 4, 5, 6, 7. Okay, let's talk about case 2. If we started with the girls, girl number 1, girl number 2, girl number 3. Boy number 1, boy number 2, boy number 3, and now boy number 4. If you write boy number 4 here, it is simply the first case. How is it different from the case number 1? It is the same case. If you place boy number 4th here, it is the same as the previous one. Now, if you place boy number 4 here, they are not standing alternately. Are they standing alternately? No, they are not. These 2 boys are standing together. So boy and a girl are not standing alternately. So this defies. When does this defy? When we have the number of elements not same. They are different. So case 2 is not happening. Case 2 is not possible. So we only look at the first case. Now let's just solve this. How do we solve this? We are starting with a boy, right? How many positions for the boys? 1, 2, 3, 4. How many boys are there? 4. So 4 factorial. How many girls are there? 3. So 3 factorial. That is the correct answer. So 24 into 6 is 120. I hope this is clear. How many different ways can 4 boys and 3 girls be standing in a row? That's a different question altogether. Because in that, they can overlap, they can interchange, whatever it is, they can stand in any particular order. That's a different question. They are standing alternately. This is the only possible case. This is not valid. How? Because you can see, if we start with the girls, since the number of girls is on a smaller end in terms of value, you cannot start with the smaller values. All right. Let's look at another question of a boy and a girl. How many different ways can 3 boys and 5 girls be arranged so that no 2 boys are together? Now just think about it. I'll not solve this question. This will be your homework. Let's see how much you have understood permutation. I'll give you an example. There are 3 boys, right? So boy number 1, boy number 2, boy number 3. There are 5 girls. No 2 boys are together. So you have to place girls in between them. You can place them anywhere, but the boys, they should not be together. They shouldn't be together. So this is one of the cases, right? This is one of the ways. You can have so many cases here. Try to build the logic and tell me what should be the correct answer. I need your responses in the chat box, because that is how I feel that you are actually following the lecture. A similar question here for 6 boys and 4 girls, so that no 2 girls are together. This will be your homework number 2. I need you all to comment the correct answers here with the solution. At least the steps, basic steps of what you are getting. Alright? Chalo. Another important aspect of permutation, that is the questions based on digits. Very important concepts. The questions based on digits. How do we solve this? Let's see. Okay. When we talk about digits, please understand we have got 2 types of questions here. First is repetition not allowed, RNA. Second is repetition of digit is allowed. In the question, you would be given somewhere that repetition of digit is not allowed, repetition of digit is allowed, no digit is being repeated, something like that. So for once and all, let's understand. RNA means repetition not allowed. And RA means repetition of digit is allowed. What is repetition of digit? I'll give you an example, no worries. We are looking out for 3-digit numbers. Okay. Using the digits. Repetition of digit is not allowed. So we can write these numbers as 1, 2, 3 or maybe 4, 2, 1. These are all valid, right? We cannot write here 9, 7, 2 because 9 and 7 are not part of the option. This is not possible. When we talk about repetition is allowed, we can write this number as 1, 1, 1 or 1, 2, 1 or 2, 2, 3 because you can repeat the digits as well. So that is what repetition allowed means. So for every question on digits, we look at these 2 types. What are these 2 types? When we talk about repetition of digits not allowed and repetition of digit is allowed. Okay. Now let's start with the question. Basic. 3 spots because we are looking out for 3-digit numbers using these digits. Now, is there any constraint? No. Are we looking out for even numbers, odd numbers, any constraint, numbers divisible by 2, numbers divisible by 5? Nothing, right? So what we do? We simply start with how many options do we have? We have 6 options. Any of the chairs can be filled in 6 ways. Next chair can be filled in 5 ways. Next chair can be filled in 4 ways. Because you cannot use the same digit which you have used. Or if I try to break this down, try to fill any of the first chair. You have 6 options. Now you have used 1 out of the 6. In order to fill any of the other chair, now you have got only 5 options. You can fill the next one in 5 ways. Now you don't have 5 options. Now you have got 4 options. So the last chair can be filled in 4 ways. The answer is 6 into 4 into 5, which is 120 numbers. Right? I hope this is clear. Alright, just a second. Somewhere we have made few mistakes. 24 into 6, not 120. 24 into 6 is how much? 144. 24 into 5 is 120. Okay. Now, repetition of digit is allowed. Now, if we say the repetition of digit is allowed and we have got 6 options, any of the chair can be filled in those 6 ways. Whatever digit we have used here can also be used here and here. So the next chair can also be filled in 6 ways. Next chair can also be filled in 6 ways. So this is 6 into 6 into 6, which is 6 cube or 216 numbers. Now please understand one thing, everyone. When we talk about 216 numbers, these 120 numbers are also part of these 216 numbers. Alright? Other than that, the extra numbers are the ones in which the repetition is occurring. Alright. Next question. What happens when in the option set we include a 0? Repetition not allowed. Repetition of digit is allowed. Now tell me quickly, everyone. Is 102 a valid 3-digit number? Yes. Is 120 a valid 3-digit number? Yes. Is 012 a valid 3-digit number? No. So that is the tricky part when we have 0 in the option set. In the previous question, we didn't have 0 in the option. In this question, we have 0 as our option. And whenever we have 0 as our option, we have to be very careful of not placing this 0 in the first spot. Because if you do that, you don't get the required answer. Because 0, 2, 3 is not a 3-digit number. Our ultimate aim is to look out for 3-digit numbers, not just numbers. So, whenever we have 0 in the option set, we have a constraint, and that constraint says ignore 0 and try to fill the first spot first. And in order to do that, use all the options other than 0. So if you look at the different options that we have here, 1, 2, 3, 4, 5, 6. In order to fill the first spot, we have 6 options or 6 ways. Now 0 can easily be coming in the second position or the third position, or the 10th spot or the unit spot or the last digit. But we have used one option out of the 6 and 0 comes back. So we have got 0 as one option plus 5 options. So we have got 6 options now. So any of the next chair can be filled in 6 ways. Any of the next chair can be again filled in 5 ways. What is the correct answer? 6 into 6 into 5. Alright. Now, repetition of digit is allowed. You are allowed to repeat the digits. So we can have 100 as our 3-digit number, or 300 as our 3-digit number, or 303 as our 3-digit number. But we cannot have 003 as our 3-digit number. Right? We cannot have 031 as our 3-digit number. So Whenever we have 0, we have that constraint of filling the first spot first, and in order to fill the first spot first, we have got only 6 options, not 7. Although the total number of options is 7, but we can only use these 6 to fill the first spot. Now, we can use all these 7 options to fill the next spot and the next spot. So this is 7 ways and 7 ways. The correct answer is 6 into 7 into 7. These many numbers. The constraint with 0. I hope you are following this digit based question. Will come to the PYQ as well, wherein you have been asked digit related questions, but this is in detail. If you understand this, you won't be having any trouble in solving these digit related questions. For every question we have got formulas as well, but I'm trying to build the logic here so that you don't remember all those formulas, and you can always try out with logic these questions whenever you are getting these as part of your examination. Now, if you have seen the strategy video, you know that you have got around 3 to 5 minutes for every particular question if you follow my strategy of solving questions. So you've got ample time to solve question. You should be knowing the logic to solve these questions. All right. Next, how many 3-digit even numbers can be formed using the digits 1, 2, 3, 4, 5, 6? Again, repetition not allowed. Repetition of digit is allowed. Okay, let's understand. 3-digit numbers, we have got 6 options, but these numbers must be even. Let's talk about even numbers quickly. Even numbers are the numbers divisible by 2. That means the last digit LD must be either 0, 2, 4, 6 or 8. Talk about any particular even number. As many digits as it might contain, we only look at the last digit of that particular number. If it has a 0, 2, 4, 6 or 8, it is considered to be an even number. Now when we look at our option set, we can have 6, 4 and 2. So with the even constraint, we try to fill the last spot first. So the last spot or the last digit can be filled in how many ways? You can place here 2 or 4 or 6. Therefore, you can write it as this can be filled in 3 ways. Now, out of the 6 option, only one option I have used here, either 2 or 4 or 6. So out of 6 options, I have exhausted one option. How many options do I have now? 5. In order to fill any of the next places, I can use 5 options. Any of the next chair can be filled in 4 ways. The correct answer is 4 into 5 into 3. These many numbers. 60 numbers. Alright. Repetition of digit is allowed. Even if you are allowed to repeat the digits, you can only have either 2 or 4 or a 6 in the last spot, and this can be done in 3 ways. Now it's up to you to repeat the digits. So how many options do you have? 6. So this can be done in 6 ways. This can also be done in 6 ways. This is 6 into 6 into 3. These many numbers. I hope you are following this. It's not that difficult to follow. I hope you are simply following these particular digit related questions based on permutations. Alright, let's look at the next one quickly. And you try to solve this. We are looking out for 3-digit odd numbers. Any odd number will not have 2, 4 and 6 at the end. It will always have 1, 3, 5, 7 or 9 as the last digit. That is the basic rule of odd numbers. So repetition of digit is not allowed, and we are looking out for 3-digit numbers. So 1, 2, 3. Last spot can be filled with either 1 or 3 or 5. So 1 or 3 or 5. How many ways this can be done? You have 3 options here, so 3 ways. You have used one option here. How many options are you left with? 5. So next year can be filled in 5 ways. Next year can be filled in 4 ways. This is 5 into 4 into 3. 60 numbers. Next, repetition of digit is allowed. Odd numbers. How many odd numbers? So you can write here 1, 3 or 5. This can be done in 3 ways. Next, you have got 6 options. All 6, any of them can be coming here or the other part. So this is 6 into 6 into 3 numbers. I hope this is clear. Alright, let's look at the next one. How many 3-digit odd numbers can be formed using the digits 0, 1, 2, 3, 4, 5, 6? Repetition of digit not allowed. Repetition of digit is allowed. Alright. 1, 2, 3. Okay. Whenever we have 0, just tell me, can you place 0 here? No, right? 0 cannot be placed here. So we are also looking out for odd numbers, right? We are also looking out for odd numbers. So the last spot can be filled in either 1, 3 or 5. So this can be done in 3 ways. Now 0 cannot be coming here, and we have already used 1, 3 or 5, 1. So 0 has been eliminated from the option set as of now, and out of 1, 3 and 5, 1 has been eliminated. So how many options do you have now? You can place here 2 or 4 or 6 or let's say 5 or 3. How many? 1, 2, 3, 4, 5, 6, 7 options we have. 0 is taken out. So 1 is taken out, and out of these 3, 1 is also taken out. So we have got 5 options. So in 5 ways we can fill the first spot. Now, let's understand this. Out of these 7, in order to fill the first spot, 0 cannot be placed here, and we have already used 1, 3 or 5 here. So 1 we have used. So we have used 2. So 5, this can be done. Now, out of 3 blocks, 2 blocks have been filled using these 7. So you have used 2 digits. How many do you have now? You have got 5 left. So this is 5 into 5 into 3. 75 numbers. Okay. When the repetition of digit is allowed, in that case, what are you supposed to do? 1, 3 or 5 can be placed here because we are looking out for odd numbers. So this can be done in 3 ways. Now 0 cannot be 0, 1, 2, 3, 4, 5, 6. 0 cannot come in the first spot because it will lead to a 2-digit number. But you can use the 1, 5, 3 or 5 here. So you have got how many ways? You have got 6 ways to fill this. Now, in order to fill the second spot, you can use any of these digits because repetition of digit is allowed. So next one can be filled in 7 ways. This is 6 into 7 into 3. So this is 6 into 21. I hope this is clear. So 126 numbers for when we tend to repeat, and when we are looking out for no repetition, the digits are not repeated. In that case, we start by filling the odd. So we have got 3 options. Now out of these 6 we have used 1. So now we have 5 here, and 0 cannot be considered. So 5 ways. Now 0 comes into play. So we have got 1 more, that is 5. Okay, let's talk about the next question. Repetition not allowed. Repetition of digit is allowed. How many 3-digit numbers? Divisible by 5. Now, the divisibility rule of 5 says the last digit of the number must be either 0 or 5. If the last digit of the number is a 0 or a 5, we can say that particular number is always divisible by 5. Look out for any multiple of 5. Let's say 5, 10, 15, 20, 25, 30, any particular number, the last digit is always a 0 or a 5. Do you have 0 in the option set? No. Do you have 5 in the option set? Yes. So 5 has to be placed here compulsorily. Now when you know for a fact that a particular digit is picked from here and placed here 100%, you know that can be done in one way. Because you are 100% sure about the placement of 5. Alright. 5 has been taken out. Now how many options do I have now? 1, 2, 3, 4, 5. So any of the next chairs can be filled in 5 ways. Any of the next chair can be filled in 4 ways. So 5 into 4 into 1, which is 20 numbers. Alright. Let's talk about repetition is allowed. When the repetition of digit is allowed, we are looking out for numbers which are divisible by 5. So 5 must always be placed here, and this can be done in one way. Now, since the repetition of digit is allowed, you can place 5 anywhere else and also the digit that you have used. So any of these next chair can be filled in 6 ways, and next chair can also be filled in 6 ways because we have got 6 options altogether. So this is 6 into 6 into 1, 36 numbers. I hope this is clear. The divisibility rule of 5. Okay, next question. How many 3-digit numbers divisible by 5 can be formed using the digits 0, 1, 2, 3, 4, 5, 6? Very important question. Always try to solve this question by forming cases. Always. Case number 1 and case number 2. Divisibility rule of 5 says the last digit can be either 0 or 5. In the previous question, we didn't have 0. So it was a cakewalk for us. But in this question, we also have a 0. So what we do? We tend to place 5 here 100% and we tend to place 0 here 100%. Now let's try to solve these two cases separately. Alright. In the first case, you know for a fact that 5 is placed here, so this can be done in one way, right? Repetition of digit is not allowed, so 5 goes out of the option. Now, we have the option set as 1, 2, 3, 4, 5, 6. 5 is out of the option set. In order to fill the first spot, can we use 0? No. Why no? Because it will lead to a 2-digit number. So 0 is also taken out. How many options do I have now? 1, 2, 3, 4 and 6. So 5 options. In order to fill the first spot, we can have 5 ways. Now 0 can be placed in any of the position. Now let's see how many options we had earlier. 7. Out of these 7 options, 2 we have used to fill the first and the last spot. So minus 2. How many options are we left with? 5 options. Because understand, we have used the 5 and any one of these numbers. So we have used 2 numbers. We have got 5 left. So next chair can be filled in 5 ways. The answer is 5 into 5 into 1, which is 25 numbers. Alright, this is not the complete answer. We can also have numbers divisible by 5 ending in 0. So we need to fill that. Now we know for a fact that 0 is at the end. So this can be done in one way. How many options do I have now? 6. So any of the next chair can be filled in 6 ways. Any of the next chair can be filled in 5 ways. This is 5 into 6 into 1. 30 numbers. What is the sum total? 55 numbers. So there are 55 numbers that can be formed using the digit 0, 1, 2, 3, 4, 5, 6, in which these are all 3-digit numbers and these are all divisible by 5. Okay. Question number 2 for this, wherein we would be looking out for numbers in which the repetition of digit is allowed, in which you are allowed to repeat the digits. Okay. With the same option set. Repetition is allowed. But since we have 5 and 0 in the option set, we'll have to make 2 cases, that is 100% surety. So 5 is placed here and 0 is placed here. Okay, let's understand. Can you place 0 in the first spot? No. But you can always place 5 since the repetition is allowed. So in order to fill the first spot, we have got 6 option. We haven't got 7 because 0 cannot come here. So this can be done in 6 ways. This is done in 1 way. And in order to fill the next one, we have 7 ways. This is 6 into 7 into 1, which is 42 numbers. Now, 0, 1, 2, 3, 4, 5, 6. 0 is placed here, we know for a fact, 1 way. Can 0 be placed anywhere else? Yes, but not at the first spot. So in order to fill the first spot, again we have 6 ways. Now 0 can be placed here, so this can be done in 7 ways. This is 6 into 7 into 1, which is 42 numbers. Final answer is the summation of these two, which is 84 numbers. There are 84 numbers in which the repetition of digit is allowed. These are all divisible by 5 when we tend to use these digits into consideration. I hope this is clear to everyone. Okay, if this is clear, let me see if you can solve this particular question. This will be your homework number 3. And if you comment this, I'd be knowing that you are actually following the lecture. This gives me certain amount of dedication to make more videos for every one of you. If you are particularly diligently following the lectures and you are responding in the comment section as well. Okay, so the question is simple, not that difficult. How many 4-digit numbers divisible by 5 can be formed using the digits 1, 2, 3, 4, 5, 6? That's it. Repetition of digit is not allowed. Repetition of digit is allowed. Take this as homework number 3. Alright, let's move forward. Take this okay, let's not take this as homework. Let's try and do this. Repetition not allowed. Numbers divisible by 2. Case number 1. What are the numbers divisible by 2? The last digit is either a 0 or the last digit is either 2, 4, 6 and 8. Since we have 0 in the option set, therefore we are trying to solve it as part of different cases. Case number 1, wherein we place either 2, 4 or 6 here. And case number 2, wherein we tend to place 0 in the last spot. Okay. How many options to fill the last spot? We have got 3 ways. How many ways can you fill? You have got 3 options, so 3 ways. Now, you cannot place 0 here. So, if you write the option set, 0 cannot come here. 0 is taken out. And out of 2, 4 and 6, 1 we have used. So you have got how many total options? You have got 1, 3, 5, 3 option plus 2 more. 5 options. So this can be filled in 5 ways. Now 0 comes into the option set and out of these 6 we have used 2. So we have got 4. So again we have got 5 options. The answer is 5 into 5 into 3. 75 numbers. Next, you know for a fact that 0 is placed here with 100% surety. So this can be done in 1 way. If this is done in 1 way, next chairs can be filled in 6 ways and the next chair can be filled in 5 ways. Numbers. The final answer is always the summation of the two cases. 105 numbers. So there are 105 numbers in which the repetition of digit is not allowed. Tell me the answer for repetition of digit is allowed. If you are allowed to repeat the digits, what should be the correct answer there? When you're supposed to repeat, when you can repeat these digits. Okay. Repetition of digit is allowed. In these cases as well, you've got two cases. Case 1 and case 2. 2 or 4 or 6 can be placed here, and 0 is placed here with 100% surety. Okay, this can be done in 3 ways. Now, in order to fill the first spot, we can pick any 6 but not 0. So this can be done in 6 ways. Now, any of these digits can be placed in the next spot. So this is done in 7 ways. This is 6 into 7 into 3. This is 6 into 21, which is 126 numbers. Okay. Now, 0 is placed here and we know for a fact. So this is done in 1 way. Now, 0 cannot come here, but any of the next digits can come here. So this can be done in 6 ways. Next spot can be filled in 7 ways. This is 6 into 7 into 1, 42. Add them up, you get 8, 6, 168 numbers. That is the correct answer for the repetition of digit is allowed. When you are allowed to repeat the digits, this is the correct answer. I hope you are able to follow up to now. Up to now, everything is clear. All right. Let's look at the next question. How many numbers between 4,000 and 5,000 can be formed with the digits 2, 3, 4, 5, 6 and 7? Now tell me, can we form a 3-digit number? Or can we form a 2-digit number? No. Why no? Because these 2-digit and 3-digit numbers are not in between 4,000 and 5,000. So any number that is between 4,000 and 5,000, that is necessarily a 4-digit number. Now, the digits can be repeated? Yes. Because how many numbers between 4,000 and 5,000? The repeated digits are also there. That is 4001 or 4002 is also an option. But 0 is not there. But you getting my point. That is 4222 is also present between these two. 222, the digits are being repeated. So this is a question on repetition of digit is allowed, but nowhere it is mentioned that repetition of digit is allowed. You have to figure out yourself looking at certain indication from the question. And these are all obvious indications. You are looking out for all the numbers between 4,000 and 5,000. There would be some numbers in which the repetition would be occurring. Okay. We have to use only these digits. Now tell me, can you start these numbers by 2? Can we have a number starting with 2? No, because that would lead to a number which is not in this range. Can we start our number by 3? No. Can we start our number by 4? Yes. Can we start our number by 5? Obviously no, going beyond. 6 going beyond. 7 going beyond. So necessarily our number is starting with 4. So we know for a fact 4 is 100% placed here. This can be done in 1 way. Right? 4 is 100% here. Okay. Now, how many options do I have now? 1, 2, 3, 4, 5, 6. We have got 6 options, and any of these 6 digits can be placed here. Can you place 4 again here? Yes, obviously yes. So you can place any of these 6 options anywhere. So the next spot can be filled in 6 ways, 6 ways and 6 ways. How many numbers between 4,000 and 5,000 can be found with the digits 2, 3, 4, 5, 6 and 7? The answer is 1 into 6 into 6 into 6, which is 216 numbers. And that is my answer. I hope this is clear. using obviously these digits. What are these digits? 2, 3, 4, 5, 6 and 7. All right. Let's look at the next question. How many 6-digit numbers can be formed using the digits 3, 4, 5, 6, 7 and 8? Repetition not allowed. Okay, let's solve for repetition not allowed. 6-digit numbers. 1, 2, 3, 4, 5, 6. What are the option? The option is 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So 6, any of these chairs can be filled in 6 ways, 5 ways, 4 ways, 3 ways, 2 ways and 1 way. This is simply 6 factorial, which is 720 numbers. Done. Okay. Next question. How many of these numbers are divisible by 5? So we are always looking out for a 6-digit number. Divisible by 5 means 5 has to be placed here. This can be done in 1 way. How many options do we have now? 5. How many places do we have now? 5. So next can be done in any of these chairs can be filled in 5 ways, 4 ways, 3 ways, 2 way and 1 way. So this is 5 factorial into 1, which is 120 numbers. Now let's understand the next question. It says not divisible by 5. Not divisible by 5. Out of total 720 numbers, there are just 120 numbers which are divisible by 5. So naturally, there are 600 numbers which are not divisible by 5. There are 600 numbers which are not divisible by 5. And that is the clear-cut solution for this. All right. Okay, so now we start. I hope the digit part is clear to everyone. If you have any queries, anything, please try to comment here so that I can solve your queries. All right. Now it's an important one, which is the repetitive permutation part. The repetitive permutation part. Very important. Please pay attention here, everyone. Okay. Repetitive permutation. Let's start with our word high, or let's start with an easy word. Let's say TCC. Tell me the number of arrangements for this. Considering all in all, that is 3 and 3. The answer could have been, if these are all different, all 3 are different, the answer would have been 3 factorial, which is 6 arrangements. Right? But if you look closely, C is repeating. C is the same, alike elements. So the answer is not 6 arrangements. And what should be the correct answer then? Let's see. What could be the possible arrangement for this? So can you say one of the arrangement is TCC. The next arrangement is T or CCT. The third arrangement is CTC. Can we have any other arrangement? Can you write it as CCT? You have already written it as. Can you think of any other arrangement? Just try to look out for any other arrangement. No. But if we go by the formula is for distinct element or different elements. Here we are talking about alike elements or repetitive elements. The correct answer is 3. So how do we get to 3? That is our question. Okay. The answer is simple. Irrespective of the digits being repeated or not, you count the number of digits or number of elements. How many elements are here? 3. So you write here 3 factorial. Now divided by the number of times factorial any of the values are repeating. So if we talk about C, it is repeating how many times? It is repeating 2 times. How many times? So the answer is n factorial upon alike elements factorial. So this is 3 factorial upon 2 factorial. 3 factorial is 6, 2 factorial is 2, this is 3. So we have got the answer as 3 arrangements. I hope you are following this. Please note down the formula here. The formula for repetitive permutation, RP. This is n factorial upon number of times p is being repeated factorial. If there are p alike elements, number of times there are q alike elements, number of times there are r alike elements, and so on. Number of times factorial. That is what we do. Very important. Number of times factorial. That is how we solve this. Okay, I'll give you example. No worries. I'll give you example. Don't worry about it. What are these? I'll give you example. But as of now, I hope this particular example is clear to everyone. The TCC part. So with the help of formula, we are getting the definite result, that is 3 arrangements. Okay. Now let's look at the word Kolkata. Is Kolkata repeating? Yes. What are the elements that are repeating? K is repeating and A is repeating. Okay. So by formula it says n factorial upon number of times p factorial into number of times q factorial and so on. What is the value for n? 1, 2, 3, 4, 5, 6, 7. 7 factorial upon what are repeating k. So k is repeating how many times? 2 times. So 2 factorial into what else is repeating? A. So number of times A is repeating 2 times. So into again 2 factorial. And that is the answer for what is the following number of arrangement without any restriction. So we write it as Kolkata. Count the number of element, that is 7 factorial upon K is repeating 2 times, so 2 factorial. A is repeating 2 times into 2 factorial. Okay. In the same manner, please tell me the answer for institution. institution. Count the number of elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So right here 11 factorial simply. Upon what are the values that are repeating? I is repeating 1, 2, 3 times. So 3 factorial into what else is repeating? N is repeating 2 times. 2 factorial. Is there anything else that is repeating? Yes, T. T is repeating 3 times. Is there anything else that is being repeated? No. So that is my answer for the number of arrangements when we have repetitive elements or alike elements. In that case, we tend to use this formula. I've already given you the formula and I've explained how this formula gives us the correct answer with the help of this basic example of TCC. Alright. So it tends to omit all those elements that are, all those arrangements that are repetitive in nature. Okay. I hope you are following this. The formula is clear to everyone with the help of this formula. Now, if not, please solve for this HIGH. Tell me the correct answer for HIGH. How many elements? 1, 2, 3, 4, 4 factorial. Is there any element that is being repeated? Yes. 2 factorial. So this is 12. 12 arrangements. Let's come to our question quickly. Homework question. Okay. Hi. Correct answer is 4 factorial upon 2 factorial. This is the number of arrangements. But in this question, we are looking out for rearrangement. So minus 1. So this is 12 minus 1, which is 11 arrangements. I hope this is clear. Alright. Let's quickly come back to this. You are given the letters of the word Kolkata from the find the following arrangements. Vowels are always together. What are the vowels in the word Kolkata? O, A, A. First write them together. Then write the next remaining letters. So out of Kolkata, K is left, L, K, T. Now, vowels are always together, so group them together. This will be taken as one unit. Now you have 2, 3, 4, 5. How many elements? 5. Out of these 5 elements, you can clearly see K is repeating 2 times. So upon 2 factorial. Now you tend to break the box. Once you break the box, you see there are 3 elements, and out of these 3 elements, A is repeating 2 times, so upon 2 factorial. And that is my answer for vowels are always together for repetitive. Same logic, but with a different approach. Same approach. I hope you are following this. If you solve this, what do you get? Let's solve this. So this is 120 by 2 into 6 by 2. 180 arrangements. You are given the letters of the word Kolkata. Again, Kolkata. 2 K's are always together. Okay. So K and K are always together. Olata. The K's are always together. 1, 2, 3, 4, 5, 6. 6 factorial. The box is taken as a single unit, but A is repeating 2 times. So 2 factorial. Now you tend to look at the box. How many elements are there in the box? 2 elements are there in the box and 2 are repeating. The answer is simply 6 factorial upon 2. 6 factorial is 720. 720 upon 2 is 360. That is the correct answer. Alright, next. The A, the L, the O are always together. Alu is always together. A, L, O. K, K, T. Okay. A, L, O, we have got 2A. Now, these are always together. This is one unit, this is second, third and fourth unit. 4 factorial upon 2 factorial for these 2K into, now break the box. How many elements are there in the box? 4. How many are repetitive? A is repeating 2 times, so 2 factorial. And that is our answer. I hope you are following this. The repetitive permutation part is clear because now we would be solving questions based on repetitive permutation which have been previously asked, and you can say we would be covering questions from the previous year as well, 2023. Okay. Consider this as your homework number 4. Write the number of rearrangements for the word thala. Thala for a reason. Okay, let's come back to our PYQs. This was asked in this year's paper, 2023. What is the sum of all 4-digit numbers less than 2000 by the digits 1, 2, 3, 4? So we are looking out for 4-digit numbers sum. So first of all, let's look at what are these 4-digit numbers. Now all of these numbers must be less than 2000. So can you start the number by 2? No. Can you start these numbers by 3? No. Can you start these numbers by 4? No. In that case, you would be getting a number which is greater than 2000. So the only possible value for the first spot is 1. And out of the options at 1, 2, 3, 4, you know for a fact 1 is straight away here with 100% surety. So this can be done in one way. None of the digit is repeated. Now, in order to fill the next 3 spots, how many options do we have? 3 options, 2, 3, 4. So this can be done in 3 factorial ways or 6 ways. So what should be the numbers? It is either 2, 3, 4 or 2, 4, 3 or 3 2 4, 3 4 2, 4 2 3, and 4 3 2. 1 is always constant, and we are looking out for the sum. We are looking out for the sum of these values. Okay. How many 4s? 4 is occurring 2 times, 3 is occurring 2 times, 2 is occurring 2 times. 4 plus 4 is 8, 3 plus 3 is 6, and 2 plus 2 is 4. 18. So this is 8. Again, this will also be 18 plus 1, 19 plus 1. Again, this is 18 plus 1, 19. And this is 6 plus 1, 7. 7998. Option A is the correct fit. This was the question again based on permutation. This year's paper, it was not that tough. Okay. Again, a question on permutations. This year's 2023. How many distinct 8-digit numbers can be found by rearranging the digits of the numbers such that the odd digits occupy odd positions and even digits occupy even positions? Okay. 8-digit numbers. So 1, 2, 3, 4, 5, 6, 7, 8. Out of the option set 1, 1, 2, 2, 3, 3, 4, 4, how many are odd? These 4 are odd. So odd places are 1, 3, 5, 7. So we have got how many odd values? We have got 4 odd values, and we have got 4 even values. Yes or no? How many odd positions do we have? 1, 2, 3, 4. We have got 4 positions for these 4 values. So odd values can be filled in 4 factorial ways, but they are repetitive in nature. So this is 2 factorial into 2 factorial. Are you following this? That is the 1, the 3's will be rearranging among themselves along these odd positions. 1 cannot be coming here. 1 cannot be coming here. 1 will always be present in the odd position. So let me quickly write down O for odd. These are the odd positions. And what are the odd values? 1, 1, 3, 3. So these 4 values can be positioned anywhere among these 4. And since they are repetitive in nature, therefore we have written 2 by 2. Okay, now let's talk about even. So these are the even positions. And what are the even values? The even numbers can be arranged in, we have got 2, 2, 4, 4. We have got 4 values, out of which 2 are repetitive in nature. So that is the correct answer. Let's quickly solve for this. This is 24 by 4, 6. This is again 24 by 4, 6. This is 36 numbers. Option C is the correct fit here. I hope you are following this with the help of, yes, this was a question based on repetitive permutation. But tell me, since you have understood the concept of repetitive permutation, is this question on the difficult end? I don't think so. Yes. Considering, if I tend to consider the level of CSAT, this was a difficult question because you shouldn't be asking question based on the difficulty level. But if you have studied this, the basics of permutation, I don't think you would be having trouble solving these type of questions. You should be preparing these type of questions for the coming CSAT, that is the CSAT 2024. You should be ready with these type of concepts with us. All right. Let's solve the next one. So you have seen in this particular video, we have tackled 2023's 3 questions from permutations. Okay, let's solve this as well quickly. From the year 2021, digit based question. Again, it's a repetitive permutation, RP we have written. Using 22333 as digit, how many distinct numbers greater than 30,000 can be formed? So greater than 30,000 means we are looking out for numbers which are 5 digit. Okay, so 3 has to be placed here, because if you place 2, you are getting a number which is lesser than these values. So out of the option set 2, 2, 3, 3, 3, one of the 3's is used. This can be done in one way. Now you have got 4 places and 4 elements. So this is done in 4 factorial upon 2 factorial into 2 factorial. Tell me the answer. The answer is 24 by 4, which is 6. Option B is the correct fit here. Repetitive permutation, digit based questions. Alright. Let's talk about the next question. A very interesting question on the year 2022 based on permutation. Very important question. Please pay attention to this question. There are 9 cups placed on a table arranged in equal number of rows and columns. Very important part. Equal number of rows and column means if you are looking out for 9 elements, please understand. There are 9 elements. Equal number of rows and columns. That means there are 3 rows and 3 columns. It's a 3 by 3 matrix. That means the row and the column are same. See, we have got 9 places. Equal number of rows, row 1, row 2, row 3. R1, R2, R3. Column 1, column 2, column 3. Okay. Out of which 6 cups contain coffee. So in order to denote coffee, I'll write it as C. In order to denote tea, I'm writing it as T. Okay. How many ways can they be arranged so that each row, not column, each row contains at least 1 cup of coffee? So you cannot place these coffees as tea, tea, tea. This is wrong, because every row must contain at least 1 cup of coffee. Now, at least 1 cup of coffee means we can start with only 1 cup of coffee and the other one has to be tea. Next, row can have 2 coffees and a tea. Next can have 3 coffees. At least 1 coffee means minimum is 1. Maximum we can go up to any number. Obviously within our constraint of, since we have 6 coffees, so we can not go beyond that, but minimum is 1. So are we following that criteria? Yes, minimum we have 1 coffee everywhere. Now, if we try to look at these solutions individually, how do we solve them? It's not necessary that coffee will be placed in column number 1. Coffee can also be placed in column number 2. So can we write this as T, C, T? It's the same thing, but it's a different arrangement. We are looking out for arrangement. So let's solve them as part of arrangements quickly. So we have got 3 elements, out of which 2 are repetitive in nature. So this gives rise to 3 ways. Next, we have got again 3 elements. 2 are repetitive in nature. It is again 3 ways. Next, we have got 3 elements and 3 are repetitive in nature. So we have got 1 way. So what is the correct answer here? 9. Now, can the rows be interchanged? Can you say the first row might contain all coffee and the third row might contain 1 coffee and other tea? Or you can always interchange the rows. It's not necessary that the first row will contain 1 coffee and 2 tea. It can be present in any of the 2 rows. So how many rows are there? 3. So this can be done in again 3 factorial ways. So 9 ways into 3 factorial ways means 9 into 6, which is 54. This is case number 1. 54 ways. Why case number 1? Because you'll see we can have one more case here. Case number 2 says, can we have 2 coffees in each row? And that is followed throughout row 1, row 2, row 3, column 1, column 2, column 3. Can we have 2 coffees here, 2 coffees here, 2 coffees here? 6 coffees done, 6 coffee cups done, and each row is containing at least 1 coffee done. All tea, all tea, all tea. Can this be a possible arrangement? Absolutely yes. How do we solve this? This is simply 3 factorial upon 2 factorial, 3 factorial upon 2 factorial, 3 factorial upon 2 factorial. This is 3, which is 27. Now, can you tend to rearrange them? Even if you rearrange them, it is not affecting. All 3 are same. So you place anywhere, any one, it will not affect. So into 1. So what is the correct answer? The correct answer is case 1 plus case 2. That is 54 plus 27, which is 81 ways. In 81 ways, can you arrange these coffees and teas in 3 by 3 column matrix? This particular question is considered to be a difficult question, and it is a difficult one to crack. Please understand. It's not that simple to crack. Yes, it might seem a bit simpler, but it was on the difficult end, to be very honest. Alright. So by far we have done almost all the questions of permutation. In the next video, we will be starting with combination, and let's say we'll do one more question on permutation wherein I'll tackle these type of questions. This basically requires the understanding of the property of a triangle. When we talk about triangles, there are certain things that we should be knowing. Alright, suppose this is a circle and we have a triangle inside this circle. For a circle, you know this is the radius, and this is, if you elongate the radius, you get the diameter, right? Any triangle that is drawn inside the circle with one of the side as the diameter, anywhere, you put it anywhere, anywhere. Let's say you put it here, this point. This angle is always 90 degree. Or since you are considering the diameter as one of the sides, you place it here. This is 90 degree. That is the property of triangle. That is, if it is inside a circle and one of the side is the diameter, the opposite angle to diameter would be 90 degrees. That is the property of this type. Now, since we have started with the properties, so let's be done with this question also. Why to keep this question? Okay, there are 8 equidistant points on a circle. Let's draw a circle and let's look at the 8 equidistant points. If you have not seen the direction sense video, do check out the logical reasoning playlist for all the reasoning topics. In direction sense, we have got 8 direction: north, south, east, west. Then we have northeast, southeast, southwest, northwest. These are 8 equidistant points on a circle. How many right angle triangles can be drawn using these points as vertices and taking the diameter as one of the sides? Taking the diameter as one of the sides. Okay. So if you take the diameter, how many diameters can be formed? 1 diameter, 2 diameters, 3 diameters, and 4 diameters. So with this, with the given constraint of the question, we can have 4 diameters. Now my question is, and let's quickly just be done with this quickly. 1, 2, 3, 4, 5, 6, 7, 8. Let's consider this diameter, just for instance. Okay, Let's try and draw a triangle here. This is 90 degree because that is property. If you draw this, this is also 90 degree. If we draw this, this is also 90 degree. If we draw this, this is also 90 degree. Again, if we tend to draw this, this is again 90 degree. And if we tend to draw this, this is also 90 degree. So with one diameter, I can draw 6 triangles. How many diameters do we have? We have 4 diameters here. So with 4 diameters, I would be drawing 4 into 6, which is 24 triangles. And these 24 triangles will be right angle triangle because of the property of triangle. Since we are taking the diameter as one of the sides, always the angle opposite to the diameter will be 90 degrees. So there are 24 triangles that can be drawn. We'll also come back with few questions on squares, triangles based on permutation or based on the permutation and the combination part. Next video would be on combination. Till then, keep commenting the questions that I've given you as homework and I'll get back to you all. Happy learning everyone. Take care. Bye-bye.